Welcome to another back of the net recording. This is just really a quick recap of Surds. Quite a few have asked for a bit of help with Surds. Let's just go through it quickly, see how you do. The first one, square root of 12 equals k root 3, and the question was find the value of k. Okay, so 12 root 3. Whenever I'm simplifying Surds, sorry, I didn't mean 12 root 3, root 12. Whenever I'm simplifying Surds, I'm looking to make the square root, or what's in the square root, as a square number times by another number if I can. So is there a factor of 12 that is square? Whereas 2 is a factor, 6 is a factor, neither of those are square, 3 is a factor, 4 is a factor, 4 is a square number. So it's 4 times 3. I can then say that is the same as the square root of 4 times by the square root of 3. Well, the square root of 4 I know, the square root of 4 is 2. So it's 2 times root 3, which we would write as 2 root, I'll rewrite that as bad too, 2 root 3. So in this case, they asked what the k was, and as you can see, the k there is going to be the 2. Let me just cross that out a bit more so it's clearly what it is. 2. So k equals 2. Now that's quite a nice question, because actually they're giving you a tip. You could have looked at this stage and said, well, I know I've got to have a square root of 3, so what do I times 3 by to give me 12? It must be 4. That's just like a hint way to do it, but I know some of you find the fact they're asking for the k a bit more confusing. The question you may get may quite simply be just simplify. Square root of 48. So I'm now going to think I need to simplify that. Are there any squares in 48? So I'm just thinking in my times tables. Have I got 48 could be 6/8 of 48, neither of those are square. 6/8 of 48, 4 times 12, that's looking nice, it's 48. Let's just say I go with 4 times 12 for the moment. So that's the same as the square root of 4 times 12. Now straight away I can say, actually, can I get 12 reduced anymore? Yeah, I can. That's 4 times 3. So it's a square root of 4 times 3. So that's the square root of 4 times by the square root of 4 times by the square root of 3. Well, the square root of 4 is 2 times by 2 times by the square root of 3. Well, 2 times 2 is 4, so it's 4 root 3. Okay. Some of you may have said, well, actually, that was a bit of a waste of time. Couldn't you just say it's 16 times 3? So it's the square root of 16 times 3, which would be the square root of 16 times the square root of 3, which is 4 times the square root of 3, or 4 root 3. Yes, you could do it like that if you wanted to. Not everyone would have spotted that factor there. But as you can see, either way, you end up with the same answer. Okay, second example, square root of 300. Straight away, I know that 300 is 100 times by 3. So that's the square root of 100 times by the square root of 3. The square root of 100 is 10 root 3. Okay, let's just draw a line under there. Next little bit, you may well be asked to expand this. So that is root 5 times by the bracket 2 plus root 5. I would normally say root 5 times 2 is 2 times the square root of 5 plus root 5 times root 5. Well, root 5 times root 5 is indeed 5. So I've now got 2 root 5 plus 5 as being my answer. I know some of you like to set it out like this in a little grid, and you will write your root 5 there, and then 2 plus root 5. 2 times root 5 is 2 root 5. Root 5 times root 5 is 5. So you would have got 2 plus root 5 in that way there. Sorry, 2 root 5 plus 5 in that way there. Okay, the next one, expand this one here. Now again, some of you would like to do the smiley face method, where you do that times that, that times that, or that, or FOIL, firsts, insides, outsides, and lasts. I can't get that, am I? Firsts, insides, outsides, last, a FOIL method some of you may use. I actually always prefer the grid method. It's so useful. You're probably sick and tired of me saying this, but actually it's reliable and it works across a variety of different topics. 2 times root 3, 2 root 3. 2 times 1, simply 2. Minus root 3 times 3. Well, root 3 times root 3 is 3. A minus times a plus is a minus, so it's minus 3. Minus root 3 times 1 is just minus 1 of root 3. Now write out what we've got. We've got 2 root 3. We've got a minus root 3. We've got a plus 2 and a minus 3. Okay, I wish I had my highlighters. I don't know who's stolen them, because I'd really like to highlight the 2 different bits there, but I can't do that, that's a shame. So I'm just going to say that I've got 2 root 3 and minus root 3 there, then a 2 and a minus 2 there. The ones I've circled are the root 3 bits, and the other bits are just the normal integers. So 2 root 3 take away root 3 leaves you with 1 root 3. Well, there's 1 root 3. 2 take away 3 minus 3. 2 minus 3 is minus 1. So we'd write that as minus 1 plus root 3. That's your answer there. Okay. I've also noticed as I've been going through here the way I do my square root signs. If I want to write the square root of 10, really I should be writing the square root of 10 as that, with the hat going right across the top. However, particularly when we move on to A-level maths, we're writing square roots off, and we very often just write root 10 like that, and we don't actually put the square root over the top. So I'm sorry if I'm not doing it every time. It's a bit of a bad habit, but it just comes from writing lots of square roots. As you can see here, I've done exactly that. I've got the root 3 there and the root 3 there. I've not put the hat across the top. I'm going to carry on like that for now because I find it easier. Right, this question, let's section that one off. It is rationalise the denominator to give answer in the form a plus b root c. Okay, where it will say a, b and c are integers. Okay, here we go. So I'm going to times the top and the bottom by the square root of 3. The denominator of your fraction is the bottom of your fraction. Rationalise means take it from irrational, i.e. the square root, into a form that's rational, a rational number. Okay. Now, you know when you're timesing fractions, do the bottoms times the bottoms and the tops times the tops. So root 3 times root 3 is going to be root 3 times by root 3. That's the bottom done. I then got 6 plus root 3 times root 3. That is the same as root 3 times 6 and root 3 times 3. So root 3 times 6 is 6 root 3. And then root 3 times root 3 is plus root 3 times root 3. Let's simplify both of those. On the bottom, root 3 times root 3 is just 3. On the top, 6 root 3, I can't simplify that. And then on the top, I'm going to have root 3 times root 3 is just indeed, 3. Okay, let's do a little bit of sorting out here. That's the same as 6 root 3 divided by 3 and 3 over 3. Well, 3 over 3 is 1. 6 root 3 divided by 3, but there's a factor of 2 in there, so that 3 will cancel with that 6 to give me a 2. So it's plus 2 root 3. So there's my answer there. A is 1, B is 2, and C is 3. 1 plus 2 root 3. Okay, little dotted line across the bottom of the sheet here, so we can do the last question. And again, rationalise the denominator. That means I need to times something to make this here not a square by the square root of 2. Well, root 2 times root 2 is just 2. Root 2 times 12 is 12 root 2. And I've got root 2 times root 2 is 2. That's minus 2. Okay, I can rewrite that as 12 root 2 over 2 minus 2 over 2. They cancel, giving me 1. There's my minus 1. And 12 and the 2, there's 6 2's in 12, so that cancels to 6 root 2. So it's 6 root 2 minus 1, which you probably write as minus 1 plus 6 root 2. So there's my A, there's my B, and that's my C. Okay, so the final answer is minus 1 plus 6 root 2. Okay, I hope that's been useful to you. Do tune in again.